Welcome to Vedic Era. Look around our planet today, and you see a world overflowing with life. We have towering mountain ranges, sprawling tropical rainforests, and vast oceans teeming with biodiversity. Because our planet sits at a perfect 23.5-degree tilt, we experience the reliable, steady rhythm of the seasons. From a distance, this blue marble looks like a permanent, peaceful sanctuary. But 14 billion years ago, there was no space, no time, and certainly no Earth. Everything in the universe was compressed into a microscopic speck, which suddenly erupted into a blinding expansion of infinite energy. As that intense energy cooled, gravity took hold. It gripped the expanding clouds of hydrogen and dust, violently crushing them together to ignite the first atoms, eventually clustering into the billions of stars that make up our Milky Way galaxy. Within that galaxy, one particularly massive pocket of gas collapsed to form our sun. Its immense gravity acted as an anchor, trapping leftover debris, dust, and helium in a scorching, chaotic orbit around it. Earth began its journey as a boiling, toxic sphere of magma, a world of pure chaos more similar to modern-day Venus than the home we know today. The mystery is how this hostile rock survived such violent beginnings to become habitable. We call this early stage the Hadean Eon. The surface was a churning ocean of lava, continuously pummeled by a relentless rain of massive meteors from the turbulent early solar system. Many of those descending rocks were actually dense spheres of frozen ice. Vaporizing on impact with the molten crust, they released massive plumes of steam. Over millions of years of continuous bombardment, those steam clouds condensed, fell as torrential rain, and slowly filled our early oceans. Just as the surface began to cool, a Mars-sized planet named Theia hurtled toward Earth. The two worlds collided at immense speed, tearing Earth's fragile crust apart and blasting billions of tons of shattered debris into space. Caught in Earth's gravitational pull, that massive ring of scattered rock and dust slowly coalesced. It locked together to form our moon, providing the gravitational drag necessary to stabilize Earth's wobble. Without that collision, our orbit would be chaotic. Without the relentless meteor strikes, our surface would be completely dry. Absolute planetary destruction was the essential prerequisite for securing the water and lunar stability that life requires. Deep within those newly formed oceans, volcanic chemicals and electrical storms began to react. These volatile conditions forced early amino acids to link together, ultimately forging the first microscopic strands of DNA. But 2.5 billion years ago, the planet plunged into a global deep freeze. Temperatures plummeted to -18 degrees Celsius, entombing the entire planet under a massive, impenetrable sheet of ice. Beneath that frozen barrier, early single-celled life faced an existential threat. To endure the extreme isolation and cold, these organisms were forced to divide and cluster together for protection, a survival response that triggered the shift toward multicellular complexity. This freeze lasted for millions of years, until a massive wave of underwater volcanic activity violently tore through the ice sheet. The eruptions pumped thick clouds of carbon dioxide into the air, trapping the sun's heat and rapidly melting the frozen crust. Surviving marine life exploded into complex aquatic plants, drawing in carbon dioxide and releasing pure oxygen. Multiplying globally, they pumped billions of tons of oxygen into the sky, replacing the toxic, methane-heavy atmosphere with a breathable one. The brutal pressure of a completely frozen world acted as a filter. That near-extinction event forced the development of multicellular life, generating the very atmosphere we breathe today. Fast forward to about 65 million years ago, the planet was ruled by massive dinosaurs, apex predators dominating every ecological niche across the land, the sky, and the sea. Then, a 27-kilometer-wide asteroid entered the atmosphere at 22,000 miles per hour. In a blinding flash, it slammed directly into the Gulf of Mexico. The impact instantly triggered magnitude 12 earthquakes and towering tsunamis. A wave of 200 degrees Celsius winds swept across the continents, igniting global fires, while a massive cloud of vaporized rock and ash choked out the sun. Within months, the resulting global winter caused plant life to wither. Without vegetation, the massive, energy-hungry dinosaurs starved. 75% of all plant and animal species on Earth were completely eradicated. Hiding deep underground and requiring very few calories, our tiny mammalian ancestors endured the fallout. The complete annihilation of the giant reptiles cleared the ecological space for those tiny mammals to inherit the Earth. Over millions of years, those small survivors branched out, eventually evolving into early primates, thriving in the dense, lush jungle canopies of Africa. Around 5 million years ago, tectonic plates collided, pushing up a massive new mountain range. This physical barrier altered global weather patterns, blocking the heavy monsoons and starving the African jungles of rain. As the trees died off and vast, open savannas took their place, our primate ancestors could no longer rely on the canopy for safety or food. They descended to the ground, stood upright to see over the tall grass, and adapted their bodies to walk, eventually evolving into modern humans. Our existence represents the direct trophy of a multi-billion-year chain of mass extinctions and violent geological disasters. Every major shift in the Earth's chemistry or climate paved the way for the next stage of our development. This graph tracks global atmospheric CO2 levels over time. Notice how the line remains low and remarkably stable for millennia, but at the far right edge, it violently spikes upward. Now look closely as a second line representing global temperature is added, climbing right alongside the CO2 spike. Humanity is burning through resources so rapidly that we are now functioning as the new asteroid strike, the new volcanic awakening. By rapidly altering the atmosphere, we are artificially recreating the exact environmental extremes that starved and suffocated the planet's previous apex species. The history of our planet tells us one thing with absolute certainty: the Earth will endure. It has survived hellish lava, deep freezes, and hypervelocity impacts. The Earth will always recover and rebuild. But if we fail to stabilize the environment we rely on, humanity will simply become the next layer of fossilized bone in the planet's endless cycle of resets.